Alrighty, so the game that we're going to be looking at today, you might be familiar with, you might not be familiar with, and it's okay if you're not familiar with it. But the game that we're playing is right there, and it is called Roulette. Now, I'm hoping that you've never played this because you only play it like in a casino, and you are not old enough to go to a casino just yet. But this is a game. I looked up an online simulator. No, I am not trying to gamble here during class. This says right there, look, free American Roulette Simulator. We are going to be looking at this game because this is a really nice way of showing probability in the real world, right? No, we are not gambling here. Gambling means you have a chance to lose something, and no one has a chance to lose anything today. No one's losing anything, so that's going to be good. So here's how the game of roulette works. Because if you don't know how it works, then we can't really play the game. So what you see on the bottom half of this screen here, that's actually a table that you would be sitting at. And you see that has all of those numbers listed there. It goes from 1, 2, 3, 4, 5, 6, all the way over here to 36. Okay? Right here is where like the teller, the casino teller standing, and that wheel that's spinning around has every single number there. Okay? So what you do is when you get there, you can place a bet on one of those numbers. Let's say I bet on 10. 10's my favorite number. I put that on 10. We push the button. We see that thing starts spinning around. We see the ball going around. That ball is getting dropped in, and it looks like it landed on number 21. I did not win, and now I'm sad because I just lost some money, right? If this was actually real, I would have lost that dollar that I put out there. That's how the game of roulette works. You put it down, you spin the wheel, you see where the ball lands. Okay? That's roulette in a nutshell. Now I'm going to switch back over here real quick because my question to you guys, this is 87A. My question to you guys is, what would we say is the sample space for roulette? What is the sample space for roulette? Go ahead and let me know in chat. And I'm going to switch over in a second, so copy that down. What would you guys say is the sample space for roulette? What are all the possible outcomes for this game? Let's see if anybody falls into the trap. Because there is a little trap here. I sure, that's great. Johnny, we'll get to that point. We'll get there eventually. All right, Andrew's thinking that it is 1 through 36. Andrew, you have fallen into my trap. Oh no, Marissa also did it as well. So I know why you're thinking it's 1 out of 36, but it's not exactly 1 out of 36. So look at the board, guys. Do you see any other numbers that we're missing besides 1 through 36? Look to the side. What about these two over here? You guys see how that's also in the wheel here? Yeah, so there's 38 different possible outcomes, right? You got tricked. You thought it was 1 through 36. I agree, it's 1 through 36, but there's also a 0 and a double 0. Now, we call this an American roulette table. American roulette tables has a 0 and a double 0. A European roulette table does not have the double 0. But we're going to play an American roulette because we are Americans here. No, I should know selling the soul. So this is how we're going to write this out. Remember, curly bracket. We're going to write it out as 0, comma, double 0, comma, 1, 2, 3. Of course, we are not going to write that all the way out to 36. That's going to be very tedious. Instead, let's just draw a couple of dots there showing that that thing is going to continue all the way to 34, 35, and 36. Okay? Hopefully that's making sense to you. That we can't forget about the 0 and the double 0. Oh, it's bad? Try leaving and coming back in. Maybe that'll help. Or I can zoom in. Sometimes leaving and coming back in helps. My next question for you guys, right? We're trying to think about this game. We'll call this B. Is each number equally likely to happen? Just like our dice game, right? We were rolling the dice. We said each number had an equal chance of coming up. For roulette, does each number have an equal chance of coming up? 0, 00, 1, 2, 3, all the way to number 36. Does it have an equal chance of coming up? What do we think? I see Andrew thinks yes. I think Sarah means yes by that YH. If you think yes, can you please explain why you think it's yes? I will be here to say I agree. It is yes. But why is it yes? Every number does have an equal chance. But why? How do we know that? How would you explain that to someone? Yes, because yes. Get out of here. Because none of the numbers is put in once. Yeah, every number shows up one time. I agree with that. Every number shows up one time. We don't see like 2 3s or 2 4s or 7 5s or anything like that. I agree with that. Particularly, I like how Brian did the rotating thing. Let's talk about that wheel that's spinning. What's important about the numbers on that wheel and where the ball's being dropped? What can we say about that wheel that's spinning around and where the ball is going to land? Because that's like what's picking the number, right? I'm curious if anyone can get that. So the ball has to land by the number. What can we say about that? About where the ball is landing. What's true about every number on there? That space where the ball has to land. What can we say about that? Oh, if your computer's running slow, go ahead and leave and come back. Sometimes that helps. Maybe restart it. No one's got it? Oh, man. Guys, what do we notice about the space where the numbers are on the wheel? What can we say about all of those spaces? Hey, Melvin, there we go. Yes, they're all the same size. Do we see on that wheel that for 32, for 20, for 7, for 11, as it's spinning, they're all the same size. So they all have an equal chance of having the ball drop in it, right? One of those things isn't like half the wheel, right? If it was half the wheel, then it would not be fair. But each number there has the same area going around that wheel, okay? So that's what we want to write down for this on our paper here. B says, are they all equally likely? That's what we want to write down, is that the numbers have an equal chance of occurring. Okay? Those numbers on our roulette wheel all have an equal chance of coming up. If you want to even add it, you could say same area. That's kind of what the word I was looking for. They have the same area on that wheel. Absolutely good, guys. All right, last thing we do before we play this game. I know we're all waiting to play it. What is the probability that you will win with one number? What would that fraction look like? Right? We know it's going to be a fraction. Probability always has to deal with fractions here. What would be the chance of you winning a game by putting one chip down on one number? Perfect, Gianni. Yes, Gianni, you did it correct. No, I haven't seen the mistake yet. Yes, it's got to be. We know we're picking one number, so we'll put the 1 on top. And remember, there's 38 possible numbers. It's not 36, right? We think it's 36. We forget about the zeros. We can't forget about those zeros. Absolutely correct. You have a 1 and 38 chance of winning this game. Do you guys think this is a game that you guys are going to win often? What do we think? Do you think that's a game we're going to win often? Yeah, Andrew says no. I don't think so. Emma says no. A 1 out of 38 chance, that doesn't seem like something we're going to win very often. But you know what? I'm going to give you all the chance right now to play this game and to see if you can win with a 1 in 38 chance. So here's what we're going to do. I'm in a second, don't do it yet. In a second, I'm going to have you type out what number you think it's going to land on. When I spin the roulette wheel, if it lands on your number and you get it, I will give you an extra credit point for today's classwork assignment. That means you will be able to get 6 out of 5 points. A little extra credit never hurt anybody. And let's be real, I never offer extra credit. So this is like a once in a lifetime opportunity here to get some extra credit. So I'm typing out spin number 1. Please put your number in after I type in spin number 1. And you need to select one number, just one, type it out. I'm going to give you 10 seconds. If it lands on your number, you get 1 point extra credit. So let's go. 10, 9, 8, get that number in. 7, 6, 5, 4. You can pick a number 2 that someone else already did. You can have matching numbers, that's fine. 3, 2, 1. Get that number in. If you have not typed that number in, I'm going to write the word stop. Any numbers after my word stop are not going to count. 0. All right, I'm putting that message in for stop. We got lots and lots of guesses on what we think it's going to end on. Oh, mine's even lagging a bit too. All righty, let's see if anyone is going to win an extra credit point. Josh, Vincent, your guys just came in late, but I will count it. I will count it. Alrighty, we're spinning it. Let's see. Is anyone getting an extra credit point today? Alright, it's going. And looks like the winning number is 27. Ooh, I see Samaya got 27. And I don't see anyone else with 27. Samaya, you are the winner. I'm going to go ahead and write your name down. Oh, Andrew, I'm so sorry. Too late. I'm going to go ahead and write that down. And you are going to get an extra credit point for that. Super, super good. Oh, Andrew, that's terrible. Can't lag. Oh, man. It's tough. It's tough. All right, so Samaya, you're going to get an extra credit point. Now, that's very hard to do it, right? Some of you are like upset because you didn't win, right? And we know that you had a 1 in 38 chance of winning, right? And that's not that much. So what I'd like to do is I'd like to go back here and let's actually find out the percentage, okay? Let's find out the percentage of what that actually is, okay? So to find out the percentage, you just got to get a calculator out. And let's change this fraction into a percentage. Okay? I know, Miguel, you picked 26. That's crazy. You were 1 off, dude. 1 off. So close. So if I do 1 divided by 38, we get this long string of a decimal, right? 0.0263. We move that decimal point over 2 spots. The chance of Samaya winning, and really all of you winning, was 2.63%. Yeah, Nyana wrote out the decimal. That's the decimal. Remember that you have to move this number over twice, the decimal point. So that ended up being 2.63. Samaya, you are very lucky. Like a 2.5 chance of winning that game. 2.5% chance. That is so tiny. And you won. That's crazy. Good for you. You want to hear something even crazier? Last class, I had in my 4th period, 2 people won it on 1 number. That was so shocking to me. So shocking to me. Let's do it one more time. Let's see if anyone else can get lucky and get the winning number. Yes, you are amazing. Yes, Nyla, we're going to get to that in a second. Yes, of course, you're going to be able to bet on more numbers. And that's what we'll look at after this last spin. So let's do spin number 2. Get your numbers in. Type them out. Another extra credit point is up for grabs. You can do the same number you chose last time. You can do a different number this time. It's up to you. I know that I have family members that whenever they go to a casino, they play the same numbers every time, right? That's their numbers. They have their favorites. They're going to stick with it. One day it's going to work. Hasn't worked yet because we're all still broke, but it might work one day. All right, let's see. I'm seeing lots of numbers. There we go. Drop in those numbers. Let's go. Let's go. All righty. I'm going to go ahead. 5, 4, 3, 2, 1. All right, I'm typing my word stop into chat so that we can get going with this game. Also, Samaya, if you win again, which is very unlikely, but if you win again, you can get 2 points, 2 extra credit points. Okay. All right, let's go. I'm spinning it. See what number we land on this time. I see a lot of people picked 15 and 16. Interesting. Number 36. All right. Ooh, Born Great comes through with some extra credit. Born Great has 36. Samaya, did you really type in 39? I'm looking at what you just typed in. Samaya, did you really type in 39? There is no 39 on the board. Ay, ay, ay.
Oh, wait. I forgot.
Oh, my gosh. That is so funny. That is actually... Okay, so let's talk about what Samaya's mistake was, because it's okay. But she wrote 39 in. Our sample space doesn't include 39, so there is 0 chance of her winning. It is okay, though. I like it. So we do have another winner, though. Born Great, you get an extra credit point. Oh, it is not rigged. Just because you don't like what the numbers ended up being doesn't... Alrighty, let's do this. The probability of winning with 2 numbers. Let's say I let you pick 2 numbers. Okay, let's say I let you pick 2. What would that fraction look like? If I let you did 2 numbers now, what would that fraction be? Ooh, so you did the reduced version, Andrew, but you made a mistake. It wouldn't be 1 over 16. Give me the unreduced fraction, and then check your work again, because it doesn't reduce to 1 over 16. Okay? I like it, Sarah. It's going to be, and Melvin, thank you. It's going to be 2 out of 38, because now we're picking 2 numbers out of a possible 38. 2 over 38, it reduces to 1 over 19. Be careful. Half of 38 is 19. Half of 32 is 16, yeah. So then if we want to know what that's going to be as a percentage, we could get our calculator out again. I could do 1 divided by 19. And we see here that that decimal is 0.0526. So that actually ends up becoming about 5.26%, which really is, if you notice, just double of our last percentage. So if you pick another number, you're now doubling your chance of winning the game. Alrighty. Let me tell you what happened in my 4th period. We did 2 rolls, right? Two spins with 1 number each. I had 2 people win both spins. It was wild. I have never had that happen in any years that I've taught this. That was crazy. That is so unlikely to happen. Now what I'm going to do is we're going to do spin number 3, and I want you to pick 2 numbers. Have a comma in between them. Pick 2 numbers, have a comma in between them. Now we're doubling everyone's chance to get that extra credit. So go ahead, start typing it out. As you type it out, I'm going to tell you, my lucky class my last period, they were so lucky. When we were picking 1 number, 2 people got it twice. When we did it this way, when you had 2 chances of winning, no one won. So I don't know if they're unlucky or if they're unlucky. I don't know how that works. All right, I gotta get my phone off. There we go. All right, 2 numbers. Yes.
every time I type, I press enter, my thing doesn't close until like 3 minutes later.
Okay, tell me what your number is, and I'll write them down.
I'm putting on 20 and I think 2.
2. Okay. Anyone else having technical difficulties that needs to phone in their number? No, we good?
No.
All right, Johnny, I'm going to mute you because I heard myself echoing. All right, I think we're good. I think everyone's got their numbers in. I'm going to type the word in stop. Let's go ahead and spin this. And let's see if anyone can get this answer. Oh, I got to switch it over. So in my last class, I forgot to switch it over. And then they said that it didn't count because they couldn't see. And no, that's not how that works. All right, let's see. Any winners for this last time? If I can need a drum roll. It's unlucky number 13. Let's see if anyone got 13. Ooh, Cassidy. Cassidy is a winner. Let's see. Nyla is a winner. Wow, 2 people won it this time. I'm looking, and I don't see any more 13s, but we did have 2 people win. Brian, nice try. No bueno, though. Wow, we have 2 people win, so now I have 4 people total who are getting 2 extra credit points. Alrighty. Super, super good. Cheater. I mean, how do you cheat this game, right? Okay, so here's the next thing I want to talk about. We're seeing how hard it is to win this game, right? It's very hard to win the game because your odds are so low. But let me explain to you how casinos work. When you have a low chance of winning, right? These are very low chances of winning. The lower your chances, the more money you can win. That's how casinos work, right? You go in there and you have a very low chance of winning, but the more you play, the higher the chance you have of winning. And so, yes, you could just bet on one number. You can bet on 2 numbers. But when you go in, let's call this part D for our paper here. Let's see, let me write it out. Part D. You'll notice on this roulette board that you're actually able to place a bet on either the first 12 numbers, the second 12 numbers, or the third 12 numbers. You see how that's being highlighted there? So if I were to do that, if I were to walk up and I were to bet on, let's do probability of winning with the first 12, what would that fraction end up being? What would my fraction be if I walk up there and write down my bets on the first 12? What is it my chance of winning now? I want to see if anyone gives me the wrong answer, because there's a wrong answer that many people fall for. And I wanted to see if anyone's going to give me the wrong answer. So if I walk in, slap my money on first 12, right? I put it right here. What does that fraction end up looking like? Okay, I'm seeing no one falling for the trap. It is 12 over 38. Okay? It is 12 over 38. So it's not going to be 1 over 12. Yeah, I saw that pop up. Not 1 over 12. It's 12 over 38 because you're still picking 12 numbers out of a possible 38. My question to you guys is, what do you assume people think the fraction is? By just looking at it highlighted, what do you think people think their odds are when they bet on the first 12? See if anyone can figure that out. Not exactly 1 over 12. That's usually not what it is. That's not the one I'm looking for. But I appreciate you throwing that out there. So no, not that one. Look at the way the board is divided. How does it look the way it's divided up right now? There we go. Perfect. The way this board looks right now, it looks like you have a 1 in 3 chance of winning, right? We see a third's there. The second 12 is there. The other 12 is there. My question to you guys is, What are people forgetting about when they walk up to this table and they put their money on first 12 thinking they have a 1 in 3 chance of winning? What are they forgetting? Because they're forgetting something. Yes, thank you so much for typing that out. They are forgetting the zeros on the side here. Okay? I hate to be the one to break it to you if you didn't know this. Casinos are a business that wants to make money. And if they can try to manipulate something to make you think that you have a better chance of winning, when in reality you don't have that chance of winning, they're going to take advantage of that to try to win your money, right? They want to make money. They need to make as much money as possible. So they are going to mess with the way things appear to try to make you think, oh, this is a sound bet. Because we see that this is 12 out of 38. Let's get that decimal real quick and see what that is. So 12 out of 38, that ends up being, what is that? 31.57%. So it's not much. And I agree it's not much. But if you walk up to that table, you might be thinking, oh, I have a 33% chance of winning. In actuality, you only have a 31.57 chance of winning. You see that subtle difference there? They're taking off what? About 1.5% chance? But that's something that's going to them because they want to win, right? They want to make that money. That's why they're there. They're trying to get you in there to take your money. Now, are you going to win sometimes? Yeah, people go to the casino, they win. That's what makes them keep going back. But the chance of you winning for that is not always going to be that great, okay? Here's my last one I want to do with you guys. When I place my chip on either red or black, my question to you guys is, what do you think people assume the probability of winning is? When they walk up and they bet on black or they bet on red, what do you think they assume their chance of winning is? What do you think in their mind? Oh, I'm going to walk up, I'm going to put it on red. I know that my chances of winning are perfect, Cassidy. They go up there thinking it's 1/2. Yeah, thank you, Marissa. They think it's 1/2. Because again, looking at the board, right, it appears that it's 1/2. Okay, because it's half of the numbers between 1 through 36, but they're forgetting about the zeros. Yeah. So, in actuality, there are 18 of those numbers are red. That's out of a possible 38. We go ahead and we type that in to our calculator to see our percentage there. It ends up being about what? 47.36%. Again, not much, right? Not much off of 50. But do you really think a casino is going to have a game on the floor there for you to play where half the time they might lose? Right? They want to make money off you. The way this is set up, they have, if we round this down and say it's 47%, they want that extra 3%. They want a 53% chance of winning because that means they might have that extra shot of taking your money. Okay? So very clear that you understand how this works, right? Gambling is gambling, right? There's risk and there's reward. The odds are stacked against you. Will you win sometimes? Yeah, you might win. But then you're going to lose a whole bunch of other times as well, right? And that's how people get addicted to this because they win one time and they're like, oh, I won. It's going to happen again. Oh, maybe I'll just put a little more money in. I'll keep putting a little more money in. And then their whole paycheck's gone. And then like they lose their house and everything and it's all bad, right? That's how quickly it can snowball. Just always remember, casinos want your money. Now, the great thing about the math casino that we're rolling here is that there is no risk, right? I'm letting you guys play right now. And there's nothing bad about you guys playing. So we're going to have one more spin. This is the final spin. You guys may pick a color. What color do you think is going to come up for our final spin? Go ahead and type out the color you want to bet on. Remember, you now have a 47% chance of winning. These are the best odds for you at the moment to win. So go ahead. We're still giving out an extra credit point. You still have a chance of winning. Okay? Type that out. I guess if you really wanted to, you could bet on green. But if we're looking at that, only 2 numbers have green. I don't think green is the best bet here. I think you're only going to bet on red or you're going to bet on black. And just so you know, there's other ways that they split the table. You could bet on even. You can bet on odd. Again, even and odd looks like 50-50, but it's not. And then you can even bet on the first 18 numbers, the last 19 numbers, right? Again, it appears 50-50, but it still isn't. All right, we all got our bets in, what we think it's going to land on for our last extra credit point. I'm typing out the word stop. I'm hitting the spin button. Let's see who's going to get some extra credit points. It landed on black 26. Everyone who wrote black is getting an extra credit point. Give yourself a pat on the back. You got that point out of a 47% chance of happening, right? Very, very cool, guys. All right, I know the people who've just voted red and still have not won. You're so upset. But here's what I'll tell you. At the Math Casino, I'm going to let everyone get a point for this one. So if you were participating with me today, you are going to get an extra credit point on this classwork assignment. So don't trip. Everyone who was playing is going to get 6 out of 5. Okay, everyone's getting 6 out of 5, except for my sticky note people who won earlier. So Samaya, Born Great, Cassidy, and Nyla, you actually will get 7 out of 5 for this assignment. Okay, so you guys are extra lucky because you got it when the odds were super low. Okay, that's my little gift for you guys, so that you guys could have that for the new year. A little extra credit to boost your score for our classwork assignment. Cool, super cool. Alrighty, we got about 15 minutes left. That's enough time for us to wrap up this lesson. We're not going to play any more rounds on this, only because we need to focus on other things now. We need to focus more on the math side of it. So let us look at that. We're still going to be thinking about roulette. We're just not going to be playing it anymore, okay? So let's go ahead. We did 87, right? This was problem 87. And let's go ahead and look at 88. Now, 88 here, we have a board for the roulette table, right? We see that there's the board there. I'm going to zoom in here. Okay, I'm zooming in. And then we're going to say that was problem 87. We'll call this problem 88. So for problem 88 here, you don't have to copy the board down. Please don't copy the board down. For 88, though, we're looking at this board, and we see that there are multiple chips placed, right? They place the chips in multiple spots there. My question to you is, what is the probability that the person who bet chip B is going to win? That's where bet B is. What would be the fraction for bet B? If I place that chip there on bet B, we see there it's kind of in the middle of 22 and 23. My tablet keeps like losing connection there. So for 22 and for 23, what is that probability going to be? Yeah, Tanya, I think you got it. They're betting on 2 numbers. That not much is changing from what we just were talking about. Whoops, still in highlighter mode. They have a 2 in 38 chance of winning the game. Okay, really, really good here. All right, let's do this. What about we look at the probability of chip D? What about chip D over here? Right there, chip D. What is the probability that chip D will win? I see chip D is kind of in the middle of 4 numbers now. They're on 7, 8, 10, 11. Perfect. I see the answers in chat. I know some of your guys' chat is lagging a bit. It's all good. But it's definitely going to be for this guy 4 over 38. If your chat is lagging, you're good. Don't worry about it. I see someone just typed in red. It's all good. I get that our chat is a little laggy. No worries. At least just copy down what we're seeing. Really, really good. All right, let's just do one more. We're not going to do all of these. If I'm looking at the person who placed their bet on E, we haven't talked too much about this, but let's see if someone can get it. For bet E, what is the probability that that person will win? Cool. Yeah, Tanya, you got it, Tanya. So being off to the side here, yeah, Marissa, you're getting it. Off to the side here means that this person is betting on this row and she's betting on that row as well. So they're actually betting on 6 different numbers. I have no idea why my tablet keeps spazzing out like that. Whoops, you can't even see what I'm writing. But there's a 6 out of 38 chance of winning. Super, super good. Alrighty. Really, really good. Cool. So let's do this. That was 88. I'm going to scroll down here. Let's go ahead and focus on problem 89. Now for 89, I'm going to give you what 2 people bet. Okay? Let's say that one person does bet A. And for bet A, they place their chip so that they're betting on number 7, 8, 10, and 11. Okay, that's what bet A is betting on. But he says, you know what? I want more odds. I just don't want to put my one chip on 7, 8, 10, and 11. I want to put my other chip, bet B. I want to put that on chip, and these are the chips, or sorry, the numbers. These are the numbers he's going to cover with that guy. 10, 11, 12, 13, 14, and 15. So he has 2 bets out on the table right now as we speak. Okay, before we really jump into this example, what's the probability that he wins A? He places his chip out there. It's hitting those 4 numbers. What's his chance of winning this game of roulette? Absolutely perfect. I couldn't agree more. I think his chance of winning there is 4 out of 38. He has 4 numbers that are going to let him win his bet A. Nothing too crazy with that one. We see now what's the probability that he'll win bet B. I'll just do it for you. I think we're starting to get this idea. He's betting on 6 numbers. So he has a chance of 6 out of 38. Okay, 6 out of 38. That's his chance for bet B. Now here's what I'm going to do. I'm going to go up here. I'm going to scroll up here. And I actually want to show you what he's doing. I got to erase this old work so we can see. Here is his bet A. His bet A is actually this chip here that we see. And he's hitting these numbers here. And then we see bet B. Bet B is actually the chip that he would have placed right here. And if he was betting that one right there, that's going to cover 15, 14, 13, 10, 11, 12. Let me zoom in here so we can see. Those are his 2 chips. He has the blue chip there, and then he has the red chip over here. My question to you guys is, what numbers will let him win both? What numbers will allow him to win both bets? What do we think? So we spin the wheel. We want him to win bet A and bet B at the same time. Absolutely perfect. I'm seeing it in chat. Everyone's throwing out there that they think it's 10 and 11. Are we understanding that 10 and 11 is literally where those 2 bets are kind of overlapping each other? Right? I highlighted them separately, but we see 10 and 11 are where the highlighting overlaps. So 10 and 11 is going to give that player the opportunity to win both his bets. Okay? So I'm going to scroll down here, and I want you to understand, by looking at the sample space of his bet, we see that 10 and 11 are the only numbers here that repeat. Does So you guys see that? 10 and 11 are in both bets. If that comes up, he's going to be able to win both of those bets. So let's write that out. Numbers 10 and number 11 will win both A and B. Okay? Number 10 and number 11 will win both bets. You already know I'm going to ask this question now. What is the probability that he'll win both bets? And more importantly, what's the probability that he wins A and B? What is that probability? Oh, be careful. Double check that answer. We know that he only wins both if he gets 10 or he gets 11. So that means he has two different ways of winning. So if we're playing the game of roulette and he has two ways of winning, I'm going to go with what Marissa wrote. Yeah, it's okay. It's okay. We're learning through this. It's fine if you messed up. It's all good. That means his probability of winning is 2 out of 38. That is the probability that he wins bet A and bet B. We call this an intersection. This is an intersection because this allows this person, as my tablet freaks out, it allows this person to win both times. Whew. Come on, Mr. Tablet. You can get through the day. We're almost done. Okay? That's an intersection. Joshua, I absolutely agree with what you wrote. Yes, we're not getting into that just yet, Josh, so I don't want to confuse anyone, but that is a very true statement which you wrote down. Yes. Alrighty. There's one more thing we have to learn before you guys go. The other one I want to talk about is what's the probability that he wins A or he wins B. So please understand that this is a subtle difference here. One of them is and, one of them is or. Okay, one of them is and, one of them is or. For the probability of A or B, I'm saying I want him just to win either. He can win A or he can win B. Go ahead and write out in chat what you think might be that answer. What do you think might be the fraction for him winning A or him winning B? It's not going to be both. What do we think? All right, Josh threw out 8 over 38. Nyana also said 8 over 38. What the heck? So that's absolutely correct. Can you guys explain how you got 8 over 38? Because that is the right answer. I'm leaving some room here because I want to show some work. How did you guys get 8 out of 38? By looking, maybe just kind of explain your thinking because it's correct. Like it's absolutely correct. It is 8 out of 38. How did you guys get that answer? No, magic is not a sufficient answer. Yeah, I do believe in math magic, but there's always an explanation behind math magic. Okay, good try though. How did you guys get 8 out of 38? Boom. Absolutely, you got it, Nyana. She looked at the numbers up here and she counted all the different numbers. Let's look back over here at our sample space. She saw that this person can win on 7, on 8, on 10, on 11. That's 4 ways. This person can win on 15, on 14, on 13, on 12. That's another 4 ways. We got 8 ways so far. But should I count this 10 and 11? The ones I haven't circled, should I count those as well and get that 8 up to 10? Yeah, no. I shouldn't count those. The reason why I shouldn't count those is because I already counted them up here, right? Those were already counted. I want to make sure I don't count those. So the biggest mistake that I see for this problem here is that students will take the probability of A. They'll take 4 over 38. They'll take the probability of B, 6 over 38, and they'll add them together. That's fine. If you want to add them together, you can add them. But you need to subtract out any overlapping numbers. You need to subtract out any intersecting numbers. Remember, the intersection was 2. There was 2 out of 38 that intersected. So over here, we need to write down a subtraction of 2 out of 38. That's how we got our answer of 8 out of 38. Probability of A plus the probability of B minus the intersection. That's how you get this. This is what we call the union. Okay? And the union and the intersection sound familiar, but they're very different. And they're different off of one word. You see A and B, A or B. That and the or are two totally separate problems there. And it's tricky. You can get messed up in it sometimes. But that's what we're doing with those two words there. Okay? Alrighty. I have one more problem for you guys to try. And after that, you are good to go. I know it's already 1:30. We're going to go over a little bit more. It's okay. We will make it through. But I do want to go over one more example so you have this for your paper, okay? So for problem 90 here, let's set up 2 more different bets. Let's see if we can find out some problems with this. So let's say that bet A has the numbers. Let's see, I got to pull up the roulette table because I minimized it. I got to see what I want. Let's say that I have bet A betting on 7, 8, 9, 10, 11, and 12. Let's say that we have bet B. And bet B is betting on all the reds. Okay? Bet B is betting on all the reds. So my question to you guys for this problem here is, what is the probability of winning A and B? What's the probability of winning A or B? Okay. Now, we might need to see the roulette table again because we are not going to be able to find the intersection if we don't know what numbers up here are red, right? We need to know what numbers are red because that will form our intersection there. So let me switch this real quick. I'm going to go over to our roulette table and let's identify which of those were red. So he was betting on these 6 numbers here. So I see 7, 9, and 12 are the ones that are red. So back over here, I'm going to circle those so I can show that they're red. Let me give you like 2 minutes to try this. Look at the example we just did. Try that out. Excuse me. And let's see if we can come up with the probability of A and B, and then the probability of A or B. Okay, same idea is happening, just different bets taking place.
How many numbers are there?
Remember, we're out of 38. Remember, for reds, I will give you this hint. For reds, remember that probability was 18 out of 38. I'll give you that one.
Oh, okay.
Yeah, I forgot. Yeah, no, that's totally fine. Because remember, if we look at the table, I'll switch it real quick. Out of the 36 here, half of them were red, so that's 18 of them. Yeah. Okay, got about 1 more minute. Alrighty, for the sake of time, I'm going to jump right into this. The probability of A and B, remember A and B means intersection. Where do these two bets overlap, right? Where are they overlapping? Well, we see that they are overlapping. Where's my thing there? There we go. We see that they're overlapping literally on the ones that I circled, right? These are the first bets for A. Those are the ones that are red. There are 3 of those that overlap. So the A and the B has a probability of 3 out of 38. Okay? Super, super good. For the union, remember, it's really just 3 different fractions that you have to set up. You have to get A, you have to get B, you have to get the intersection, add the first 2, take out the other one you don't want. So, probability of A. Whoops, there's 6 of them. So the chance of you winning A is 6 over 38. The chance of you winning B, winning the red bet, that's 18 out of 38. But remember, we need to subtract out any that overlapped. That's the intersection. We saw that there were 3 that overlapped. So those are our 3 fractions. So we take 6 plus 18, that makes 24. But we got to do 24 minus 3. We end up with 21 over 38. That's our intersection. That's our union. Again, intersection is where are they overlapping. Union is this or that. Either can happen. Intersection is we want both happening. Okay? Very subtle difference. One word and or changes the whole problem. Okay?